Greetings everybody, so we're going to be taking a look at question 4 of the 2021 Methods Exam 2. We already did a video on question 3, I'm going to be doing question 4 now. This is a probability question, just typed this question up quickly, it took like 15 minutes or so, but anyways. What do we have here? A teacher coaches their school table tennis team, adjustable ball machine, the speed measured in meters per second, and this is the normally distributed random variable W. The mean is 10, standard deviation is 0.8. Determine probability that W is greater than or equal to 11. So we're going to go to our catalog, let's go to methods probability, and go to normal distributions, find probabilities, click enter. This is a greater than or equal sign, so we'll just go for option 1. The mean is 10, standard deviation is 0.8, and the A value is 11, so we get 0.105. This is to 3 decimal places, so 0.106. Okay, next find the value of K in meters per second, which 80% of the ball speeds are below. Okay, so this is a normal distribution, and we want to find the K value here, such that everything below here is 0.8, or 80%. Okay, how do we do that? That's just normal inverse. We're trying to find the X values down here. So we're going to go ahead and go to probability, normal inverse, and then click enter to run. Given probability is 0.8. This is a bounded above, so option 1, and the mean is 10, standard deviation 0.8, so that K value is 10.67. This is to 1 decimal place, I guess it's 10.7. Teachers adjust the height setting for the ball machine. Machine now shoots ball high above the table tennis. Okay. Unfortunately, new height setting, 8% of the balls do not land on the table. P hat, random variable, sample proportion of the balls that do not land on the table in random samples of 25 balls. So what's the probability that it doesn't land on the table? 0.08. And we want to find the mean and standard deviation of P hat. So we can assume this is large population and so on. So we can go ahead, go to method stats, go to P binom info for the binomial distribution stuff. Sample size is 25. Probability of success is 0.08. And we don't need that probability table. We're after the mean and standard deviation. So the mean is, so E of P is, my handwriting's horrible today, is 0.08, and the standard deviation of P is exactly 0.054. They didn't really say decimal places, so I guess if you want, you could use the formula. What was it? Standard deviation of P hat equals square root of P 1 minus P over N, and sum in the values down under CAS if you want exact answers. I'm not too sure, they don't really specify, but I'll just leave it at that. Use the binomial distribution to find probability that P hat's greater than or equal to 1, sorry, just greater than, correct in 3 decimal places. So we want to convert from P hat to X, where X is binomially distributed, 25 trials, because it's 25 balls, and probability of success, or in this case it's a failure, but we're thinking of the do not land on the table as our success, of 0.08. So we want to find the probability that X is greater than 0.1, but we just take this and multiply it by 25. But what is that going to be? That's 2.5. X is greater than 2.5. But that's the same thing as the probability. Now, if X is greater than 2.5, it has to be 3. We are discrete here. So X is bounded between 3, and the upper bound is 25. So for binomial number of trials, the maximum is 25. So 25 here. So let's go to the CAS. I'm going to go to book button, probability, binom, CDF, and number of trials is 25, and probability of success is 0.08. Lower bound is 3, upper bound is 25, and it's 0.32, or 0.323. Cool. Teacher can also adjust the spin setting on the ball machine, random variable x, probabilities, density function, piecewise function. So let's go ahead and define f of x equals piecewise function. I'm going to go to, which template was it? This template. Now there's three different kind of functions here, but we don't really need to worry about the zero because that's just outside our domain. So we have x over 500, 0 less than or equal to x less than or equal to 20, and we also have 50 minus x over 750, and this is 20 less than or equal to x and less than 50. Okay. Find the maximum possible spin applied by the ball machine in revolutions per second. Well, the spin is the x values, and we can see that the x values can only go up to 50. Anywhere above 50, the probability of that happening is 0. So the maximum possible spin would be 50. Find the median spin. So if you want to find the median of a probability density function, it's not actually in the probability folder here. I named it probability 2. I think it's because I did an update or something, but if you have the programs, it's in the normal probability. So we can go to continuous info, plug in our f of x, and what's the lower and upper bound of where it's not 0, it's from 0 to 50. So what do we get? We get the median, it's right over there, 22.613, just in one decimal place, so 22.6. If you want to show working out, because this is 2 marks, you would want to let the integral from 0 up to some point b of f of x, dx, be equal to a half. And you can solve for that b value using the solve command, and that should also give you 22.6. Find the standard deviation of the spin, correct in one decimal place. Well, here it is right over here, 10.27. Oh, no, it's one decimal place, so that's 10.3. Okay. The teacher adjusts the spin setting so that the median spin becomes 30 revolutions per second. This will transform the original probability density function to a new probability density function g, where g uses some rescaling over here. Now, what is f of x? If you take a close look at what f of x is, notice it's just a bunch of linear lines, I guess. And if you want to graph this out, we can see that from 0 to 20, it passes the origin and has some gradients here. So this is from 0 to 20. And then from 20 to 50, well, if you plug 50 into the seconds part of the piecewise, you get 0. So at 50, you actually get a horizontal intercept. So this is 50, and you'll go all the way back down here. So not quite symmetric, but yeah, something like that. So what this is doing is x over b, and if you have some x divided by something inside of your function, that's actually a dilation by a factor of b from the y-axis. So imagine kind of stretching this out away from the y-axis or stretching into the y-axis or something. And what that a is doing at the front is just compensating for that stretch, because if you stretch out, the area will change when a probability density function has constant area of 1. So it kind of compresses down if you stretch outwards. Okay. Sorry, how do we do this? Well, what we can do is we can define g of x to be equal to a times f of x over b. We already have x or f of x defined, which is nice. So what do we know? We know that the median is 22.6. Okay, so 22.6, it's probably around here. It's not quite 30. We want the median to be exactly 30. So the idea is we want to kind of stretch out this way a little bit. We want to stretch it outwards a little bit in order for that median to move towards 30 from 22.6. Okay. So notice there's two variables, a and b. So ideally, we want two equations to solve simultaneously. So what could they be? Well, we know for 1, the area must be preserved. It must remain at 1. So we can say the integral from 0. Now, we want the integral of g. G is our new probability density function. We want this guy to be equal to 1. Now, 0 is going to stay fixed. It's because no matter how much you dilate this portion of the graph, or this point right over here, we'll use yellow, it's always going to stay fixed at 0. You can stretch it out a little bit more. We always start at 0. Okay, what is going to change is that upper terminal. It's going to get dilated away from the y-axis. Now, this is a dilation by a factor of b. So initially, our red graph, our f of x, is at 50. It ends at 50. So for our g of x graph, it's not going to end at 50. It's actually going to end at 50 times b because we're dilating by a factor of b. Now, this is one equation. Now the second equation we can get by noticing that we want the median to be equal to 30. So we have the integral from 0 to 30 of a g of x dx is equal to 1/2. That's what it means for the median to be 30. The probability of the distribution between one endpoint and 30 is equal to 1/2. Okay, so these guys over here are what we want to solve simultaneously for a and b. Now there's no a's in here, but a is actually hidden in the definition of g. So in the CAS will be solving for a because when it sees g, it thinks of a times f of x over b. So let's try to solve this simultaneously. I'm going to go solve, and simultaneous equation, let's use the template again. It is this template here. We want the integral, so shift plus the integral from 0 to 50b of g of x dx. We want this guy to be 1. Second of all, we have the integral from 0 up to 30 of g of x dx. Oops, wrote dx in the wrong spot. Yeah, g of x dx to be equal to 1 over 2. And we are solving this simultaneously for a and b. Let's see. Oh dear, this is not good. Oh, there we go. So that took a very long time to load. And that was on a computer. So if you use this method in the actual exam on your actual CAS where the CAS performance isn't as good as the computer's performance, then that might be a bit of an issue. But yeah, we see that we get a equals 0.75. How many decimal places? 2. 0.75. And b equals 1.32. So find the values of a and b, blah, blah, blah. 2 decimal places. So yeah, you've answered that question. So yeah, that's the probability question. Programs work well for this question, especially the first part over here, especially this part down here, because you've got the median and standard deviation all in one program, which is nice. Maybe this one here. I am planning on releasing a new update where these values here are actually exact values. So in case they don't specify, like in this question, you have the exact values. And if in case you need approximate values, then you can just press Control Enter. But yeah, that's probably going to be in the next CAS update. Yeah. Nice question though. A lot of easy marks here and there if you use the programs. But yeah, let me know if you want me to do more questions. I've done question 3, question 4. If Worms Math Academy doesn't upload anymore tonight or anything else tonight, I might consider doing those. But yeah, that's all.